In this video, we're going to look at direct and inverse proportion. Let's begin by looking at what it means for things to be directly proportional. Imagine we had a shop that was selling pens and pens cost 5 pence each. Let's look at the number of pens versus the total cost. So if you just bought one pen, that would obviously be 5 pence. If you doubled the number of pens, so to 2 pens, you would need to double the cost. So 5p times 2 is 10p. And if you tripled the number of pens to 3 pens, you would need to triple the cost, so 15 pens. And this would apply to any number of pens, so if you wanted to do 30 pens, 1 times 30 is 30, and then you would need to multiply the cost by 30, so 5 times 30 pence is £1.50. Now this relationship will apply to any starting and finishing number of pens. So if you started at 2 pens and multiplied it by 15, you would get 30 pens. You would need to multiply the cost of 2 pens by 15 to get the cost of 30 pens. You can also do this in reverse. So if you went from 30 pens down to 3 pens, you would divide by 10. Here you would divide the cost by 10, so £1.50 divided by 10 gives you 15. When two things are related in this way, we say they're directly proportional. So for this one we could say, the number of pens is directly proportional to the total cost. It also applies the other way around. The total cost is directly proportional to the number of pens. If two things are directly proportional, then when you graph them, they always produce the same sort of shape. So if we take a graph of the number of pens against the total cost, well, if we bought 0 pens, that would have 0 cost, so there would be a point at 0, 0. Then for every extra pen, we would need to add 5 pence. So for 1 pen, that would be 5 pence, 2 pens, that would be 10 pence, 3 pens, 15 pence, and every time you would add 5 pence, and it would form a lovely straight line like this. So whenever two things are directly proportional, the graph of them will form a straight line that goes through 0, 0. If we use algebra to represent the number of pens in total cost, for example, the number of pens is going to be n and the total cost is going to be c, then we could write that c is directly proportional to n. The symbol that I've written here could be read as is proportional to. So this says c is proportional to n. For this particular graph, we actually know its equation. It would be c equals 5n. Since to get the total cost, we multiply the number of pens by 5. This number 5 here is known as the constant of proportionality. So whenever two things are directly related, there's always a constant that you multiply one of them by to get the other one. It won't always be 5, of course, it just depends on the question. If you don't know the constant of proportionality for one of the questions, we usually use the letter K to represent it. Let's have a look at how exam boards tend to write these questions. So they may say, A is directly proportional to B. When A is 18, B is 3. And we could be asked to work out an equation that connects A and B. To start this question, we read the statement A is directly proportional to B and write this down mathematically. Using that symbol from before, A is proportional to B. Now if A is directly proportional to B, there must be some constant number that we multiply B by to get A. And we're going to call that number K. So we say that A is equal to K multiplied by B. Our goal in this question is to try and work out the value of K. The next thing to do is substitute in the values given in the question. We know that when A is 18, B is 3. So if we replace A with 18, we end up with 18 equals, and then we have K, and then we need to replace the B by 3, so it's multiplied by 3. K multiplied by 3 is just 3K, so we have 18 equals 3K, and we can solve this to find K by dividing both sides by 3. If you divide the left-hand side by 3, 18 divided by 3 is 6, and if you divide the right side by 3, you get 3k divided by 3, which is just 1k. So we've now found the value of k is equal to 6. So the question asked us to write down an equation connecting A and B. We wrote down that A was equal to KB, but we now know the value of K. So we're going to write that out once more, but replace the K with a 6. So A equals 6B. This is the equation that connects A and B, so we finish this question. It is very common for questions like this to have a follow-up question which asks you to find a value. So for instance, it could say find the value of A when B is equal to 50. To do this, you take the equation that you formed in the previous part, so A equals 6B, and you substitute in the value of B. So we've been told that B is 50, so A will equal 6 times B, which is 50, so 6 times 50, and 6 times 50 is 300. Now they could do this the other way around as well, so they could ask you to find the value of B when they give you a value of A. For instance, find the value of B when A is 66. We take the same formula again, but we replace A with 66. So this time it's 66 equals 6 lots of B, and if you divide both sides by 6, you'll find that B is 11. Let's have a look at another example of this. So this time we're going to use different letters, but C is directly proportional to D, and we've been told that when C is 10, D is 15, and we need to work out that equation that connects C and D. So this question tells us that C is directly proportional to D, which means we can write that mathematically as C is proportional to D. Since they're directly proportional, there must be some constant that we can multiply D by to get C. So we replace that proportional symbol with C equals KD. Our goal is to find the value of K. To do this, we substitute in these values. So replace C with 10, and then it's K multiplied by D, but we know that D is 15. This gives us 10 equals 15K, and to find the value of K, you divide both sides by 15. If you divide the left by 15, you get 10 over 15, and if you divide the right by 15, you get K. So K is equal to 10 over 15, which simplifies to 2/3. So now that we've found the value of K, we can rewrite this here, but substitute in the value of K. So C equals 2/3 of D. So that's the equation connecting C and D. Let's do a follow-up question. So find the value of C when D is equal to 36. We take the answer to the previous part of the question, and we just substitute D for 36. So C is equal to 2/3 multiplied by 36. This is the same as 2/3 of 36, which is 24. So C is 24. Now let's try one that's a little bit more difficult. So this time we're going to say that E is directly proportional to F squared. And when E is 36, F is 3, and we need to work out that equation connecting E and F. This one's different because rather than E being directly proportional to F, it's directly proportional to F squared. This is going to change the way we answer the question ever so slightly. So we're going to start in the same way by writing down this statement here mathematically. So E is directly proportional to F squared, so E is proportional to F squared. Then since they're directly proportional, we know there must be some constant number, which we call K, that you can multiply by F squared to get E. So we can write down that E is equal to KF squared. We still substitute in these numbers, so let's replace E with 36, and then we have K multiplied by F squared. So rather than multiplying by 3 this time, we're going to multiply by 3 squared. So we have 36 is equal to, and then it's K times 3 squared, and 3 squared is 9, so this is 9K. Now we can find the value of K by dividing both sides by 9. 36 divided by 9 is 4. So 4 is equal to K, or K is equal to 4. Now that we have the value of K, we can write this out once more, but replace the K with a 4. So E is equal to 4F squared. and that's the answer to this part of the question. And then for a follow-up question, find the value of e when f is equal to 10. So let's take the answer to the previous part, and we're going to substitute f for 10. So e is equal to 4 lots of f squared, and that's 4 lots of 10 squared. 10 squared is 100, so this is e equals 4 times 100, and 4 times 100 is 400. And let's try one more question where it's slightly tricky still. So this time g is directly proportional to the square root of h. And we've been given some values for g and h, and we need to find the value of g when h is equal to 25. There's two things to note about this question. Firstly, we have square root h here. That's different to what we've dealt with before. Secondly, they haven't actually asked us to work out an equation connecting g and h. They've gone straight for the follow-up part of the question. In order to answer a question like this, we're still going to need to work out that equation though. So let's begin by taking this statement here and writing it down mathematically. G is proportional to the square root of h, which means there must be some constant k which we can multiply square root h by to get g. So g is equal to k times square root h, or g is equal to k root h. Now let's substitute in the values we've been given. So g is 2, so 2 equals, and then it's k times the square root of h, which is the square root of 16. Now you should know the square root of 16 is 4, so we have 2 equals k times 4, which is 4k. Now we can find the value of k by dividing both sides by 4. If you do 2 divided by 4, it's 0.5. If you divide 4k by 4, you get 1k. So the value of k is 0.5. So let's go back to this line here and write that out once more, but replace the value of k with 0.5. So g is equal to 0.5 square root h. Now that we've formed this equation, we're ready to answer the question. The question wants us to find the value of g when h is equal to 25. So we're just going to substitute 25 in for h. So g is equal to 0.5 times the square root of 25. The square root of 25 is 5, so we have g is equal to 0.5 times 5, and 0.5 times 5 is 2.5. In all of the questions we've looked at so far, the two things have been directly proportional to each other. We're now going to look at when things are inversely proportional to each other. We need to first of all understand what we mean by inverse proportion. Imagine we had a swimming pool, and there were two taps that could fill this pool. We turn on both of these taps and they both add water at the same rate, which fills up the pool, and let's say it takes 6 hours. Let's have a look at the number of taps and how long it takes to fill. So the number of taps here was 2 taps, and the time it took to fill that pool was 6 hours. Now let's imagine that we actually filled this same pool with the same sorts of taps, but we doubled the number of taps to 4 taps. Well, if you double the number of taps, you're not going to double the amount of time it takes. If we have more taps going, the time it takes will actually go down. In fact, if we double the number of taps, the time will need to be halved. So if we halve 6 hours, we get 3 hours. So in this one, we doubled the number of taps, but we actually halved the amount of time. And if we do this again, let's double the number of taps from 4 taps to 8 taps, well, we would need to halve the time. So we halve 3 hours to get 1.5 hours. So if we continue to double the number of taps, we'll continue to halve the amount of time. But what if we wanted to know how long it would take with 3 taps? This is a bit trickier. We can spot a pattern if we look at the ones we've worked out already. When we had 2 taps, it took 6 hours, and if you do 2 times 6, you get 12. When we had 4 taps, it took 3 hours, and if you do 4 times 3, you also get 12. When we had 8 taps, it took 1.5 hours, and 8 lots of 1.5 is also 12. So when things are related in this way, they will always multiply to give some constant number. So we know we've got 3 taps, and we need to multiply it by something to get 12, well 3 times 4 is 12. So 3 taps would actually take 4 hours. When things are related in this way, where they multiply to give a constant number every time, we say they're inversely proportional to each other. So we could say the number of taps is inversely proportional to the time it takes to fill. And that applies the other way around as well. The time to fill is inversely proportional to the number of taps. Now, if you draw a graph of these, it looks different to when we had directly proportional. So let's draw a graph of this, and we'll have the number of taps and the time to fill. Now, when you have a really low number of taps, like 1 tap, the time to fill is very high. And then if you double the number of taps to 2 taps, the time to fill halved, so half as long. And then every time you add a new tap, the time to fill decreases, but by a decreasing amount. Every extra tap you add has less of an impact on the overall time. So if we join up these crosses, they actually make a curve that looks like this. This curve is a reciprocal curve, and it will never touch either of the axes. If we use algebra to describe the relationship here, the number of taps is going to be n, and the time to fill will be t. So we could have t is proportional to, now rather than being proportional to n when it was directly proportional, it's going to be proportional to its reciprocal, 1 over n. Just like when we did directly proportional to, we can replace that proportional symbol with some constant k. So t is equal to k times 1 over n. If you did k times 1 over n, you would just get k over n. So we end up with t is equal to k over n, as opposed to t equals k times n, which was when it was directly proportional. This value k is still the constant of proportionality. In this example, we actually know the value of k again. It's the number you get when you multiply the time it took to fill by the number of taps. Whenever we multiplied those two together for this example, we always got 12. So in this one, t would equal 12 over n. Let's have a look at how this could be written in an exam question. So they might say that a is inversely proportional to b, and we'll be given some values of a and b, and then asked to work out an equation connecting a and b. So this time, since they're inversely proportional, we're going to write that a is proportional to 1 over b, which allows us to write down that a is equal to k over b, where k is some constant that we need to find. Next, we substitute in the values, so a is 16 and b is 3. So we have 16 is equal to k over 3. Now we solve this to find the value of k. So multiply both sides by 3. If you multiply the left by 3, 16 times 3 is 48. And if you multiply by 3 on the right hand side, you'll just be left with k. Now we go back to this step here and write this out one more time, but replace the k with 48. So a is equal to 48 over b. Now for a follow-up question, find the value of a when b is equal to 12. So we just take the equation from the previous part, and we substitute in the value of b for 12. So a is equal to 48 over 12, and 48 divided by 12 is just 4. So a is equal to 4. Let's have a look at a slightly harder one. So we're going to stick with inverse proportion again, but this time c is inversely proportional to d cubed. And we'll have some values of c and d, and we need to work out the value of c when d is equal to 2. So this is another example of a question where they haven't asked you to work out that equation connecting c and d, but we're going to need to do it anyway. So let's start by writing c is inversely proportional to d cubed. That c is proportional to 1 over d cubed. This allows us to write that c is equal to some constant k divided by d cubed. Now we substitute in the values we've got, so c is 4 and d is 5. So let's replace the c with a 4, so 4 equals k over d cubed so k over 5 cubed. To find the value of k, we multiply both sides by 5 cubed. On the left, this is 4 lots of 5 cubed, and on the right, this is k. 5 cubed is 125, so we do 4 lots of 125, which is 500. So the value of k is 500. Now we go back to this step here and write this out once more, but replace the k with 500. So c is equal to 500 over d cubed. Now let's take the equation, and we've been asked to find the value of c when d is 2. So let's replace the d with 2, so c is equal to 500 over 2 cubed. 2 cubed is equal to 8, so we've got c equals 500 over 8, and if you do 500 divided by 8, you get 62.5. Sometimes exam boards like to ask questions on direct and inverse proportion when they're in a table. Let's have a look at some examples for these. So you may be told that x is directly proportional to y, and then given a table of values that you need to complete. Remember, when x is directly proportional to y, there's some constant k, so that x is equal to ky. We just need to work out what that constant is. Now if they give you a table like this, you'll always have one pair of values. So in this table it's the 20 and the 5. You can see they're paired up. So we need to work out what we would do to get from 5 to 20. To get from 5 to 20, you would multiply by 4. This is effectively telling you the value of k is 4. So if we know y, we could get the x value by multiplying it by 4. So if we look at the first missing value, we can just multiply 3 by 4 to get 12. This also means that whatever the value is on the right hand side, multiplied by 4 must give 2. So to work this out, we can actually do it the other way around by doing 2 divided by 4, and 2 divided by 4 is 0.5. But what if it says they're inversely proportional? So A is inversely proportional to B, and we have this table here. So if A is inversely proportional to B, we know there's some constant, so that A equals K over B. Once again, you can see we've got a pair of values here, this 10 and 5. Now if this were directly proportional, you'd be looking at how you get from 5 to 10, which is multiplied by 2. But it's not directly proportional, so we don't do that. If you look at the formula on the right hand side, A equals K over B, and multiply both sides by B, you'll get AB equals K. This tells us that when you multiply A and B together, you always get the same constant number, which is something we knew from before. Remember the taps question, when you multiplied the number of taps by the time it took to fill, we always got 12. So in this case, when we multiply A and B together, we should always get the same number. So if we multiply the pair we have, 10 times 5, that's 50. So when we multiply any of these pairs, we need to get 50. So for the first missing value, we've got B is equal to 1, so 1 times something is 50, and 1 times 50 is 50. So A must be 50. And for the second missing value, we've got A is equal to 4, so 4 times something is 50. So if you do 50 divided by 4, you find the value of B, which is 12.5, since 4 times 12.5 is 50. So this is how you do it if it's inversely proportional. But what if it says something like this? X is directly proportional to y squared, and we have a table of values for x and y. So if x is directly proportional to y squared, we know there's some constant k, so that x equals ky squared. But we don't have y squared in the table, we have y. I would recommend you create an extra row for this table and call it y squared. To get the y squared values, you just square any of the y values. So we know some of the y values, we know when y is 1 and y is 2. So if we square those, 1 squared is 1, and 2 squared is 4. Now we do need to complete the row of y values, but since x is proportional to y squared, I'm going to ignore the row for y at the moment. Now I'm going to look for a link between x and y squared. Since they're directly proportional to each other, I must be able to multiply the y squared by something to get the x. Since I've got a pair of values in the middle, I'll look at the 4 and the 24. What do I multiply 4 by to get to 24? Well, that's multiplied by 6. So I must multiply all of the y squared values by 6 to get the x values. So we can find out the first missing x value by multiplying 1 by 6 as well, and 1 times 6 is just 6. Now if we look at the missing values on the right hand side, we need to multiply this missing value at the bottom, which we don't know, by 6 to get 150. So if we divide it by 6 instead, we'll find the value for y squared. 150 divided by 6 is 25. Now we're ready to look back at that row of y values, and to get the y value, if you know the y squared value, you would just square root it. The square root of 25 is 5. So we've now completed the original table, and that's that question done. Sometimes exam questions have more than 2 variables. Let's have a look at a question that has 3. So for this one, we're told that x is directly proportional to y squared, and we're given some x and y values. But we are also told that y is inversely proportional to z, and we're given some y and z values. And we need to find the value of x when z equals 160. So this question is going to be a little longer and worth more marks. First of all, we're going to look at the relationship between x and y. We've been told that x is directly proportional to y squared, so we can write that x is proportional to y squared. This means there's some constant k, so that x is equal to ky squared. Now I've called this constant k1 because there's going to be more than one constant in this question. Then I substitute in the values I've been given in the question, so we're going to substitute x for 90, and then we have k1, multiplied by y squared, so multiplied by 3 squared. 3 squared is 9, so we would have 90 is equal to k1 times 9, which is 9k. You could divide both sides by 9 here, and that will give you k1 is equal to 10. So I can go all the way back up here and replace k1 with 10, so I end up with x equals 10y squared. Now I'm going to look at the relationship between y and z. So y is inversely proportional to z. So we could write that y is proportional to 1 over z, which allows us to write y is equal to k over z. And this time I've used k2 so as not to confuse with k1. Then we substitute in the values given in the question, so y is 16 and z is 5. So 16 is equal to k2 over 5. Then if we multiply both sides of this by 5, 16 times 5 is 80, and on the right hand side, the 5s would cancel, so we just have k2. So we found the value of k2, that's 80. Then if we go back to this step here, we can replace the k2 with 80. So we end up with an equation y is equal to 80 over z. So we've now found a relationship between x and y, and also one between y and z, and this will allow us to answer the question. The question was find the value of x when z is equal to 160. So let's take both of those equations, and we're going to substitute in z for 160. Now we can't substitute it into the first formula since there's no z, but we can in the second. So if we replace the z in the second formula with 160, we have y is equal to 80 over 160, which would simplify to 1/2, so y is equal to 0.5. We can now take this y value and substitute it into the first equation. So x is equal to 10y squared, let's replace y squared with 0.5 squared. So x is equal to 10 lots of 0.5 squared. 0.5 squared is 0.25, so x is equal to 10 lots of 0.25, and 10 lots of 0.25 is 2.5. So we end up with the answer to this question as x equals 2.5. Now we're going to have a look at one more question where there's more than two variables, and this type of question is quite popular for Excel in particular. So we have p is directly proportional to q to the power 3, and we're given some values for p and q, and we're also told that q is inversely proportional to r, and some values for q and r. This time, rather than working out our value, we've been asked to find a formula for p in terms of r. To do this, we're going to find the link between p and q, and also the link between q and r. So let's start with p and q. So p is directly proportional to q to the power 3, so we could say that p is proportional to q to the power 3. This means there's some constant k, so p is equal to k1 times q to the power 3. Now we substitute in the values of p and q, so 24 equals k1 multiplied by q to the power 3, and we know q is 2, so 2 to the power 3. 2 to the power 3 is equal to 8, so we have 24 equals k1 times 8, or 8 lots of k1. Divide both sides by 8, and we find that k1 is equal to 3. So if we go back to this step here and replace the k1 with a 3, we end up with p equals 3q to the power 3. Now let's look at the link between q and r. Q is inversely proportional to r, so q is proportional to 1 over r. This allows us to write that q is equal to k2 over r. We've got some values for q and r, so let's substitute those in. Q is equal to 5, so we have 5 equals, and then it's k2 over r, and r is 2, so k2 over 2. Multiply both sides by 2, and we find that 10 is equal to k2, so we can go back to this step here and replace the k2 with a 10. So we have the equation q is equal to 10 over r. Now we're ready to find a formula for p in terms of r. So if we take the two relationships we've already found, p is equal to 3q to the power 3 and q is equal to 10 over r. So here we have p in terms of q and also q in terms of r, but we've been asked for p in terms of r. So we want a formula that starts with p but doesn't have any q's in it and instead has r's. So what we'll do is take the first one, p is equal to 3q to the power 3, but we're going to substitute the q. We know from the second one that q is equal to 10 over r, so we can replace that q to the power 3 with 10 over r to the power 3. Now all we need to do is simplify this, so we've got p is equal to 3 times. If you cube the fraction, we're going to do 10 cubed, which is 1000, and r cubed, which is r cubed. Then we can multiply these together. The 3 is just 3 over 1, so if you multiply numerators, 3 times 1000 is 3000, and 1 times r cubed is r cubed. So the answer is p equals 3000 over r to the power 3. Earlier in this video, we looked at the graph when two things were directly proportional to each other. For example, if y was proportional to x. If we draw the graph of y against x, it will produce a straight line. We also looked at what the graph would look like for inverse proportion, so if y was proportional to 1 over x. The graph of this one was a curve that looked like a reciprocal graph. To help you remember the shapes of these graphs, you could imagine replacing the proportional symbol for an equal symbol. So when trying to do y is proportional to x, think of the graph of y equals x. You should know that's a straight line graph that goes through 0, 0. When doing y is proportional to 1 over x, think of the graph of y equals 1 over x. That's a reciprocal graph that looks like this. You also need to know a few more graphs. So let's have a look at when y is proportional to x squared. This is going to be similar to the graph of y equals x squared. If you drew the graph of y equals x squared, it makes a nice U shape like this that goes through 0, 0. Now we don't want the negative part of this since we only want the first quadrant here, so we just draw in something that looks like this. You may also be asked about the graph of y is proportional to x to the power 3. To do this, we'd think about the graph of y equals x to the power 3. This would be similar in shape to the graph of y equals x squared, but it would go up faster, since when you start cubing numbers that are above 1, they start getting bigger quicker than if you square those numbers. For example, 5 squared is 25, but 5 cubed is 125, so you'll get much bigger values. Finally, we have the graph of y is proportional to the square root of x. For this, we need to look at the graph of y is equal to the square root of x. Now this graph actually has a similar shape to the graph of y equals x squared, but just reflected over. So it actually looks something like this. You'll need to be able to recognize and sketch out these graphs in your exam.